Hello. I am coming to you guys on from a phone booth in a library, and I just thought I would get another video out of the way before this meeting that I have right now. Cool. Okay, so today we are discussing nuclear physics. But full disclosure, I am not a physics major in any way. I'm not that smart. And so this is going to be nuclear physics for dummies. I'm just going to get the very basics out of the way, including basically like the atomic bomb, what nuclear fission and fusion kind of even are, and why everybody's freaking out about nuclear fusion in the news, right? And so if you are truly a beginner and don't really care about physics at all, then this is the video for you. Cool, so let's get started. So the number one thing, atoms, A-T-O-M, atoms. Everything is made out of atoms, right? You are made out of atoms, I am made out of atoms, the universe is all made out of atoms. So computers are made out of atoms, this wrapper is made out of atoms. Atoms are these little kind of fundamental units, kind of like Lego blocks, that basically make up everything in the universe. But atoms can be broken apart. So atoms are not like these kind of black boxes. Atoms have a little center, and they have little kind of things that fly around the center, right? So if you've ever seen like a science logo, right, like that thing, that's an atom. Right, so atoms have these little kind of fundamental particles called protons and neutrons in the center, right? So think of like these little marbles. Think of like a bunch of marbles like all packed together in like a circle, like or like a kind of giant like pile like that, right? And then there are things called electrons that fly around in like orbits around the around the nucleus. And so you don't need to remember all those names, but just remember that there are basically like a bunch of protons and neutrons. Like there are a bunch of like little marble things that are all packed together in the center, and that form the nucleus. Right, so nucleus means center, and then there are all these kind of things that fly around the orbit. Cool. So that's what an atom looks like, and atoms have different sizes, right? So some atoms have 2 protons. Some atoms have 5 protons. Some atoms have 100 protons or 200 protons, things like that. And those are what elements are, right? So if you've ever seen like the periodic table, right? So hydrogen, helium, neon, uranium, things like that. Those are basically what those mean, right? Those are just like different sizes of atoms, right? So atoms come in different sizes, and so each atom size is basically what an element is. Cool. Okay. So that's all background information. Okay. So let's start with the Manhattan Project, or the atomic bomb, right? So which is where most people will have heard of nuclear physics, or just even the word nuclear, right? So the atomic bomb. So basically, the big kind of realization there was that you can take a very heavy, very large atom, right? So for example, a uranium has over 200 protons in its kind of center, right? And you can shoot a particle at this very heavy center, like that, and then it'll break apart, right? So it'll send those little particles flying in every direction. But then, since those particles are sent flying in every direction, they will hit other uranium atoms nearby, and those particles will also hit other centers, and that will send more particles flying in every direction, right? So it's a chain reaction, right? So think about you have just like a giant pile of like marbles held together in like a kind of like bag, right? But you have a bunch of them, right? If you break one, right, then the marbles are sent flying out and they hit other bags, and then those bags also explode, and the marbles in those bags also explode in every direction, and they hit other bags, and so forth and so forth. It's just like a chain reaction. Basically like a game of pool ball, right? Like if you hit one kind of pile of balls, then they kind of split apart, and they form a chain reaction. And so that's what's meant by a chain reaction. And so that releases so much energy, right? The act of breaking apart a nucleus of an atom releases so much energy that you get the power of an atomic bomb, right? And the reason it releases so much energy is because this bond between between the protons and neutrons in like the center of the nucleus is so powerful, because it's not supposed to break, right? Like if if this was easily broken, then we couldn't exist, right? Because like we would all just be falling apart all the time, right? So this is like literally like one of the most fundamental forces in physics, because this force needs to be really strong for any of us to exist. But scientists figured out a way to break it apart, and because it's so strong, it releases a bunch of energy. And so now and then when you form a chain reaction based on that, you just get a giant explosion, like, and that's what the movie Oppenheimer is about. And so you should watch the movie Oppenheimer because it's a really good movie, and it kind of explains that whole process. Cool. And so that is called nuclear fission. Nuclear fission. So fission means breaking apart, right? And so nuclear fission literally means you break apart a nucleus. Nuclear fission, and that's called an atomic bomb or a nuclear bomb, for obvious reasons. Cool. Okay. Oh, and by the way, nuclear reactors also work this way, right? So So currently, all nuclear reactors work by nuclear fission, but instead of a bomb, you use that chain reaction to boil water, and so then the boiling of the water releases energy, and that energy is used in a lot of things, right? So that's what a nuclear power reactor does. Cool. Okay, so let's move on to nuclear fusion. So fusion is in the news a lot. Everybody's talking about nuclear fusion. So just to be clear, nuclear fusion has not been sustainably achieved in a power reactor environment yet. And so it's kind of like this kind of pie in the sky for a lot of people, but everybody says that nuclear fusion is like the gold standard for energy generation. Once you have nuclear fusion, then you basically have infinite energy for everybody on Earth forever. And so it's a kind of a very, very big gold standard for whoever reaches nuclear fusion, kind of will pretty much own the energy grid for forever. Cool. So what is nuclear fusion? So as you might have guessed, it's the opposite of nuclear fission. So fusion means melding together, right? So whereas fission, you shoot a particle at a kind of pile of like a bag of marbles, and then the marbles explode. Here, you're taking two atoms and then you're fusing them together to form a slightly larger atom, and that is even harder. It's even harder. And so think of, for example, you are melding two metal things together, right? So you have like a metal block and another metal block, and you're supposed to meld them into one large metal block, right? You would need to have extremely high temperatures first of all, right? Because you need to melt both of them enough so that like they fuse together and form one kind of coherent whole. And so that's kind of analogous to what you need here. You need extremely high temperatures to even get the atoms in a state where they can do that. And so here, as opposed to nuclear fission, fusion requires very light atoms, right? So like one or two protons, right? So here, it's the most often used one is hydrogen, which is the lightest atom, because if you're trying to break something apart, then you need something really big. But if you're trying to fuse something together, then you need something really small, right? And so that is that's why bombs created using nuclear fission are called hydrogen bombs, right? So hydrogen bombs already exist. Hydrogen bombs have kind of been tested, and they're so powerful that the trigger, like the kind of the match that you need to light a hydrogen bomb, is a fission bomb, right? So like literally like the type of atomic bomb that was dropped on Hiroshima and Nagasaki, you need that bomb as a matchstick to start the chain reaction to ignite a hydrogen bomb. And so hydrogen bombs are several times larger than the atomic bombs that everybody knows today. They have never been used in war, and hopefully they will never be used in war, but that's kind of what they are. Yeah, and so the reason why everybody says that nuclear fusion is kind of the gold standard is because number one, there's no accident of like a Chernobyl style accident, right? Or there's no chance of a Chernobyl style accident because the conditions required to keep everything that hot are so fragile that if everything shuts down or there's an earthquake or something like that, then the mechanism used to keep everything that hot itself would shut down, and so it's not sustainable. And so it's so hard to do that there's no chance of like leakage, right? Because just having a machine that is that can stay hot for that long in and of itself is so difficult. So that's that. And also, this is how the sun makes energy, right? So the reason the sun is able to do this is because, again, the sun is extremely, extremely hot. And so at the center of the sun is, so the sun is basically a giant nuclear fusion reactor. And so the sun obviously has lasted for a very long time, will last for a very long time. And the reason why the reason why everybody is kind of going after nuclear fusion is precisely because we would be basically creating like an artificial sun of our own choosing, right? And so there's a lot of talk about, should we keep it on Earth? Should we put it on the moon? Should we keep it in space? Stuff like that. But in any case, if we can actually harness literally the power of the sun to produce almost infinite energy, then that would be great. Right now, the big problem is that, again, it requires extremely hot conditions. And so right now you need to put in more energy than you can get out of it, right? So let's say you get like 5 units of energy to get it that hot, but then you only produce 4 units of energy, right? Then every time you run it, right, it's a loss of -1 unit of energy, right? So it doesn't really kind of do anything. But recently, I think at MIT or something like that, they briefly, like for a split second, got it to produce a positive sum of energy, right? So it was like 0.1 of some unit, but let's say they put in 5 units of energy and they got 5.1 units of energy for half a second, something like that. But even that is kind of a sign that this is possible in a sense, right? It's possible to kind of harness the power of the sun to generate energy in that way. Cool. Okay. I hope this was somewhat helpful. Again, I'm not a physics major in any way. I don't really know a lot about physics. I don't really like physics even. But I just watched Oppenheimer, and so I thought I would kind of very briefly explain what nuclear fusion, fission, like all those words even mean. And I hope that this helped somebody who is either studying for their homework or just wanted to kill some time. So cool. All right. See you guys.